All right, welcome to your video lecture all about energy. This is going to be a two-day note set, so you will do part of your notes today, part of your notes tomorrow. If you're online on Thursday and Friday and you would just prefer to get them all done in one day, that is fine. I will not be upset if you do them early, but they are not due until Friday. So here's your first video lecture. This is a long one, so it's definitely going to be broken up in two parts. We are now ready to move away from the molecular side of energy and look at energy on a large scale. So what do we use this energy for? We learned that cellular respiration is the process that takes glucose and a little bit of oxygen and creates carbon dioxide as well as water, but also energy, and that's the energy that powers our cells, makes our cells able to do things like grow and multiply and attack things, maybe if they're a immune cell or if they're a blood cell, to transport your oxygen. So it's the energy and ATP that actually allows us to do everything with our bodies, from our small things like breathing to our large things like swimming and jumping and playing kickball. So I'm really excited to do these notes with you guys. You're going to watch the video lecture and fill in the blanks as we go. So tell me, do you think that this activity uses energy? My swimmer right here? Hopefully you've told me yes. Do you think the capturing of prey by a Venus flytrap uses energy? Hopefully you were able to tell me yes. Do you think that something like dancing uses energy, like these two people right here? Hopefully you've told me yes. And by the way, these aren't just two people. This is the scene, the lift scene from Dirty Dancing. What about this? My whale eating here. Does that use energy? Hopefully you've told me yes, and hopefully you've always also noticed in this picture all of that garbage. Not only do sea turtles accidentally eat garbage, but other marine organisms can be impacted as well. That's why it's very important to clean up the outdoors and pick up litter and make sure your trash goes into a trash can and not into our waterways like our rivers or our oceans. How about this? Does this use energy? Hopefully you've told me yes, the biting uses energy, but not only that, digestion uses energy. So even when you're just sitting still and not doing anything but breathing and digesting, your cells are using energy. What about this? My plant growing. Does this use energy? Hopefully you are able to tell me yes, we use energy to grow. All organisms do. So plants, animals, and even our microorganisms like our bacteria and protozoa use energy to grow. What about this? My cat sleeping. Does this use energy? Hopefully you were able to tell me yes, you always use energy every single moment of your life as long as you are living. Even when you're sleeping, you're using energy. Be that not as much, but you are still using energy. Hopefully today we are going to be able to meet these objectives. We will see by the end of the lecture. We want to define energy and explain why it's needed. We want to identify the sources of energy in our diet. We would like to understand how energy needs change throughout life, to understand that energy the energy needs of different activities, to define energy balance, and to explain problems associated with energy imbalance. So our very first goal was to describe what energy is. When we look at a physical perspective, energy is defined as the power used to do work or do something, or to produce heat or light. Energy cannot be created or destroyed. That's one of our laws. That's one of Newton's laws. I'm pretty sure, about 97% sure. But it can be changed from one form to another. So we are never destroying or creating energy. The energy that we had at the beginning of the time is the same as the energy that we have now, and a million years from now that energy will still be the same as what we have now. But what we do see, and it's very easy to see, is that the energy changes from one form to another. If you stick your finger in a light socket, you can see that change of energy from electrical energy to actually electrical energy inside of your cells in the form of stimulus. We change energy when we digest things, from the chemical bonds of food to the mechanical energy that we use to power our cells. Energy is measured in kilojoules, kg, or megajoules. Hopefully you practice the word joules. Joules is typically how we describe energy. Kilo, remember, those are our lost my train of thought. Those are our SI, or System International measures. The kilo means that it is 1, 2, 3 times bigger than our base joule unit. Megajoule is actually 1, 2, 2 spaces bigger than a kilojoule. So a megajoule, we didn't learn about the prefix mega, but it is 2 steps above kilo, so that's very large. When we're talking about, so that's our SI system, which is what we typically use as scientists, but we're in the United States, so we're still under the imperial measurement system, and typically we describe those in kilocalories when we're talking about energy and the energy that we get from food. 1 kilojoule is 1,000 joules. 1 megajoule is 1,000 kilojoules, or a million joules. 1 kilocalorie is 100 calories, and 1 kilocalorie is about 4.18 kilojoules. Remember, when we use the imperial system, it doesn't divide as smoothly as the SI system. So energy comes from our food. We just learned this. We hopefully have figured this out. If you do not eat or drink anything, you will not have energy. And we know that when we don't eat or drink anything, we end up dying. That's because we need the energy from food in order to survive and do our cellular processes. Energy is provided by carbohydrates, proteins, fats, and some alcohols. It is metabolized and used by our bodies. Here, when we talk about alcohols, we are not only talking about the above-age adult beverage, but also some of our other substances can be considered alcohols as well that do not do what the adult beverage alcohol does to your body. Carbohydrates, proteins, and fats, and our alcohols are broken down into smaller compounds, which are then oxidized in the cells of the body, called respirations. So basically, that second paragraph says that we use the carbohydrates, the proteins, and the fats. We break them down into smaller compounds, hint, hint, nudge, nudge, glucose. And those glucose molecules are oxidized, meaning we add oxygen and glucose. And we know that when we combine glucose and oxygen, we create not only carbon dioxide and water as a byproduct, but also energy in the form of ATP, adenosine triphosphate. All right, so we know that we get our energy from the food. And by the way, just a reminder, where does our food get the energy from? If we're eating a yummy piece of spinach, we know that our spinach got the energy from the sun. If we're eating a also yummy piece of bacon, we know that our pig got the energy from whatever it is they ate. Eventually, if you trace it all the way back, something ate a plant, and that plant got the energy from the sunshine. So if I ever were to ask you, hint, hint, on a test, where our energy comes from, you should be able to identify for me that our energy comes from the sun. Energy provides us with nutrients. Energy in the diet is provided by the nutrients, the carbohydrates, the proteins, and the fats that we eat and consume. So we know, if you talk to a dietitian, which, by the way, a nutritionist isn't licensed. A dietitian has either a bachelor's degree or a master's degree. So when you're talking about somebody when you're looking for help about nutrition, you want to go to a dietitian, not a nutritionist. A dietitian would tell you that 1 gram of carbohydrates provides 16 kilojoules of energy. 1 gram of protein provides 17 kilojoules of energy. And 1 gram of fat provides 37 kilojoules of energy. Energy in the diet from alcohol. So alcohol provides the body with energy. However, it is not considered a nutrient because it is not essential for survival. 1 gram of alcohol can provide 29 kilojoules of energy. People who regularly consume excessive amounts of alcoholic drinks derive much of their energy intake from alcohol. They may also suffer from nutritional deficiencies and alcohol-related diseases, though, because of this. We said it's not a nutrient because it doesn't give you all the nutrients you need to survive, so you couldn't survive just on alcohol alone. Not that any of you would. Too much alcohol can lead to a lot of diseases, liver disease, because alcohol is a toxin. The reason why scientifically people get drunk when they drink alcohol is because your body is filtering the toxins of the alcohol. It's trying to filter it out of your body. So if you drink one drink, it's trying to filter it, and some people can filter that one drink out and be just fine. They don't feel the effects of it. When you drink too much and you reach your tolerant level, the body is no longer able to filter out that toxin of the alcohol. Because your body cannot filter the toxin of the alcohol, you start to feel the effects of the alcohol on your body, the blurred vision, the slurred speech, the issues with your motor functions, your movements. It's because you have poisoned your body enough, or put enough of a toxin in it, if you don't want to use the word poison, put enough of a toxin into your body that your body can no longer filter it out. That is scientifically how people become drunk. Just thought that is an important thing to say, so that I just thought it was an important thing to say. I want you to think about it scientifically when you are of age. If you ever do drink, what is actually happening to your body? You are putting a toxin in it. And Wernicke-Korsakoff syndrome, which is another alcohol-related disease. The reason why we get liver disease when we have alcohol is because the organs responsible for filtering out toxins is your liver. So if you stress your liver out too much, that's how we can get the liver disease. Some types of liver disease can lead to jaundice disease, where your liver can no longer filter out toxins, or even your system can go septic, which means that you are not filtering out any toxins at all, meaning that not just the alcohol toxins, but the regular toxins that you might accidentally intake aren't filtered anymore because you've killed your liver. That's why alcoholism is definitely a disease, and something that none of you hopefully will get in the habit of doing. Moving on from alcohol though, energy in the diet. The energy provided by a food or drink depends on the amount of carbohydrates, proteins, alcohols, and fat it contains. Gram for gram, carbohydrates provide less energy than protein, fat, and alcohol. Look closely at the following examples of foods high in carbohydrates, fat, and proteins. We have got white bread. 100 grams of it has a total energy of 93.1 kilojoules. As far as how many carbohydrates it has in it, it's very high in carbohydrates. Most of the energy comes from the carbohydrate intake, 737.6 to be exact. There's very little fat found in white bread. 59.1 kilojoules of energy comes from the fat. And our protein level, we have 134.3 kilojoules in white bread. Let's look at some other food. Butter. So the same grams of butter has 3,061 kilojoules of energy. It has 0 carbohydrates in it. Butter is mostly fat, so 3,052.5 kilojoules of energy come from the fat, and only 8.5 come from the protein. Oh boy. So let's look at 100 grams of tuna. 100 grams of tuna has 421.7 kilojoules of energy total. Most of that, you can see, comes from the protein compounds right here, with a little bit of fat. Tuna does not have any carbohydrates in it. So which nutrient contributes the most to energy? What do you think? Realizing these stats, which one gives us the most energy? Hopefully you were able to identify that our fats give us a lot of energy. Okay, so let's talk about how we balance that energy. So experts have estimated that the average requirement for energy for the average requirement